In learning objective B, we're going to investigate the opposites theorem. So that means let's take a measurement and look at its opposite. So for example here, the measurement they want us to look at is pi over 6 radians. What is the opposite of pi over 6? That's negative pi over 6. We're also going to look at, for example, we'll go to the degrees. What if we look at 72 degrees? What's the opposite of 72 degrees? It's negative 72 degrees. So let's just focus on two of these scenarios. Let's look at the pi over 6 and the negative pi over 6, and then the 72 degrees and negative 72 degrees. What happens if we find the sine of two angles that are opposites, or the cosine of two things that are opposites? Well, if you put this in your calculator, what you're going to find is that the sine of pi over 6 is going to be equal to 0.5. The sine of negative pi over 6 is negative 0.5. Now if we look at the cosine of 72 degrees, that ends up being 0.309, and the cosine of negative 72 degrees is positive 0.309. So what we notice is if you have two either radians or degrees that are opposites of each other, their sine values will always be opposites of each other, whereas their cosine values will always be the same. So here it is, letter B. And this can be a handy theorem if they were to give us, for example, the sine of pi over 6, and they said it was 0.5, and they just asked what is the sine of negative pi over 6, technically I would not need a calculator for it. I know that the sine values of angles or radians that are opposites will also be opposites themselves. So let me show you how they actually write the theorems. This one right here says, if I look at the negative angle and if I look at the positive angle, the cosine values are the same. And let's do an example. If we look down here, let's assume that this is the angle measurement. Now, if they want us to move opposite of the theta, so if theta is the original angle, the opposite just means make it a negative. So we move the negative angle measurement. Negative just means go backwards. So move the same amount of measurement, but go backwards. So on the regular normal angle, we land here for this positive angle. But for the negative angle, we would land right here. So if you look at it, think about how you travel to both points. On the cosine values, they're saying these cosines are the same because here's what happens. From the origin to get to the red point, I would go left and up. To get to the blue point, I would go left and down. Remember, the left movement means cosine. So to get to both points, I still have to move the same distance to the left. Therefore, the cosine values will always be the same, or the x values will always be the same. Now, let's look at the sine values. Sine just means the y movement. Look what they've said here. Here they say, if I find the sine of my negative angle, so my negative angle is this guy, it's going to be equal to the opposite of the sine of the positive angle. This was the positive angle, and that's the sine. Well, the sine values are the y's. Again, if we travel to them, to get to the red dot, I have to go to the left and up. To the blue, I go left and down. So this I had to go up, this I had to go down. I'm going the same amount, I'm just going in the opposite direction. Therefore, their sine values, as you can see right here, are going to be opposite of each other. Now the last is tangent. Remember, tangent just means the slope of the line that gets created by the angle. Well, if you look at the slope, by the way, at the red dot, or the red angle, it's this. That's going downhill. If you look at one at the blue angle, it's this. That's going uphill. They are going to be the same slopes, but they're just in opposite directions. So this says here, the tangent of the negative angle, so this guy right here, so the slope of this angle is going to be equal to the opposite of the tangent of the positive angle. Well, here's the positive angle, here's the tangent. So all they're saying is take the slope of this guy, make it negative, and you will get the slope of this guy. Or use the formula. Remember, tangent is just sine over cosine. because if you have the sine and cosine values, you can plug them in here and see what the tangent is going to be. So let's do this example. I want us to sketch it on the unit circle and then show you how to find the answer. Here's what this says. Suppose that the sine of an angle equals 0.15. So let's just stop with this again. Remember, sine says the y value of an angle. So I'm going to just say this, the y value of an angle. I'm going to put that in words because that's really, when I look at this notation, is all it says. Well, the y value of the angle is 0.15. So what they're telling me is that I know this about the ordered pair. Well, where do we land on the unit circle for this? Well, I don't know if I go right or left, but I do know I go up about 0.15. So up about 0.15 would land me maybe here. Now, a lot of the times they'll tell me which quadrant I should be in. Let's assume they want me to be in quadrant 1. So if it's quadrant 1, by the way, that's going to be for all the thetas between 0 degrees and 90 degrees. And we'll do and equal to. So now we're just going to be looking at this region here. So what that means is if I go back to this y value of going up, it means they want me to move over to this spot. So this actually is the angle they're talking about. This is the theta movement that they just moved. What do we know about this particular ordered pair? Well, we know that it's some x movement, but I know the y movement is 0.15. Okay, now here's the question. Part A says this. Find the sine of the negative of the angle. Well, this is the angle movement right here. So if I take that same angle movement and I go negative of that, it just means go down. So the negative angle is going to sit right there. It's the same magnitude, but the opposite direction. So that's this ordered pair. Well, if you just think about it logically, how do you travel there? To go to the blue original angle, you would go right and up. To go to the red one, you're going to go right and down. You're going to go down, so this changes right here to a negative 0.15. So the answer here is negative 0.15. Now make note, if they had asked me about the cosine values, one thing I can tell about this is the cosine values here and here are going to be identical, because to get to both of these ordered pair points, I'd have to go the same amount right. So the cosines are the same, but the sines themselves will always be opposite. And that's how the opposites theorem works. I want us to jump to this one and try one more. Let's practice the sketch. On this scenario, we're just going to focus on the opposites theorem. So here they are telling us that the cosine of x equals negative 0.3. So remember, the cosine of x, or maybe they could have said this instead, the cosine of theta equals negative 0.3. That means the same thing. The only difference is here they've chosen to use theta, here they chose x as their unknown. It doesn't matter. But what does this mean? If the cosine of an x, or my angle, is this value, here's what I know, is that the x value of the ordered pair is negative 0.3, but I don't know the y. Again, they would normally tell me which quadrant to be in. So let's assume this time they're going to tell us we want the angles to be in between 90 degrees and 180 degrees. So that's going to be in the quadrant 2 region. So let's sketch this. The x value is going to be left, 0.3 is maybe about right there. So then I'd have to decide, do I go down or do I go up with this? Well, on this one we are going to go up because they're telling us that this should be, again, in this particular quadrant. So here's the angle they're talking about. That is the theta, or in this case, it's the same as x. Now, let's figure out how to use this. What if they asked me this for the opposites theorem? Find the cosine of negative x. Or let's again maybe said, if you want to see the theta instead, means the same thing. Okay? If this is the theta or x movement, to go negative, you just go backwards, the same magnitude, and you're going to draw and see where you land. Now this is the negative theta or the negative x. Okay, think about how to travel. Again, to the red one, we're going to go to the left and up, to the blue, left and down. So the cosine value, what we know at this particular ordered pair is that. So here we actually had to go negative 0.3 and then we went up. So here to the blue we go negative 0.3 and down. So this ordered pair is negative 0.3 and something else. So what is the cosine of the negative angle? It's right here. The answer is negative 0.3. For some additional practice, let's take a look at this scenario. Let's sketch the sine of an angle is negative 0.2. Remember, the sine means the y value. That means I don't know the x, but I know that. So to sketch it, negative 0.2 is roughly about right here. Again, I want to know which quadrant I should be in. So let's say that they said theta should be in between 270 degrees and 360 degrees. So that tells me I know I should go over here to the right and not to the left, which is quadrant 3. So the angle they're talking about is roughly right here. So that is our theta. And we'll write the ordered pair down. I don't know the x, but I know the y is negative 0.2. Okay, let's just focus again on the opposites theorem. This one says here, find the sine or the y value of taking that angle and going opposite. Well, this is their current angle, which is this direction. So the opposite of that means I need to go this direction. Just for this scenario, so I land right here. Okay, fine. To travel to this spot here, again, I had to go right and down 0.2. To travel to the new blue, I go right and I go up 0.2, which means it's a positive value. So did the answer to this question, what is the sine of negative theta? It's 0.2.